try some examples for the Laplace transform. You are asked to determine the Laplace transform of sine squared t and hyperbolic of cos 3x. Let us try to solve the Laplace transform of sine squared t. From the list of the formulas in the tables of Laplace transform, we know that there is no formula for sine squared t. However, we have the Laplace transform of sine or cos itself. That means if we want to do Laplace transform of sine squared t, we will have to reduce the power. With that, you will need to refer to the common functions of trigonometry. Find whichever functions having sine squared, so that the sine square can be replaced by any other cos or sine which have a lower degree of power. From here, we have identified cos 2a equals to 1 minus 2 sine square a. With that, copy down the function here, rearrange in the manner where sine square equals to 1 per 2, 1 minus cos 2t. Substitute this into the Laplace transform functions, you will get this. And with that, you can actually separate the Laplace transform into two terms as indicated here. Now you can refer to the table for the Laplace transform of 1 and also Laplace transform of cos 2t. Based on the formula here, the outcome will be 1 per s and also s per s squared plus a squared. The a here is equals to 2. Substitute into the formula and solve it. Combine the two functions, you will get the final solution. Now we look into the Laplace transform of cos squared 3x. From the tables of Laplace transform, there is no solutions for the cos square at. Instead, you have sines and cos at. You will need to refer to the formulas from the trigonometry in order to reduce the square into power of 1. The formula is obtained here. Rearrange it, you get this. Substitute this into the functions here, you will get this, which the Laplace transform can be done separately in two terms. Obtain the solutions from the tables of Laplace transform for the cos and also for the constant 1. Substitute the relevant value into the formula. Combine the fractions. Simplify the solutions. You will get the final solution here. Let us try another example. You are asked to find the Laplace transform of these functions where the omega and alpha are constants. Referring to the formulas of Laplace transform, you find that the formulas cannot be used to resolve this. There is no t behind the alpha. The formula can only resolve sine omega t, but is unable to resolve sine omega t plus alpha. With that, you will need to expand this sign. Use the formulas for the trigonometry. You may expand it. The 3 here will be a constant. Therefore, after expansions, you obtain this. The Laplace transform of these functions can be done in two different terms. You know that alpha is a constant. The cos alpha or the sine alpha, it will also be the constant. Therefore, you can actually take out the cos alpha and sin alpha from the functions of Laplace. That leads to you only need to do Laplace transform of sin omega t and cos omega t. From the table of formula, these are the solutions. Substitute the relevant value into the formula, you obtain this. Rearrange it, simplify the solutions, you will get this.